This is the exponent properties lesson on negative exponents. This is from Monday, October the 29th. So let's take a look at what's going on in these examples, and we'll be able to come up with our rule. This will actually be our final rule for exponents. So if you see the quotient 2 squared divided by 2 to the 5th power, we can write that with repeated multiplication as shown in this box. 2 squared means 2 times itself, and 2 to the 5th power means 2 times itself 5 times. If we cancel out, because we know that 2 divided by 2 is 1, and again 2 divided by 2 is 1, so we can cancel out, that leaves us with 3 2's on the bottom, so that's where they got the 2 to the 3rd power, and then we just simply have a 1 in the numerator. So that is what you get when you look at it with the expanded repeated multiplication. Now, if we use our quotient rule, which told us that if you are dividing the same base, you subtract the exponents, look what happened right here. 2 to the 2 minus 5 power, which is 2 to the negative 3. Now, what I want you to realize is that this and this are both equal. They're equivalent. This is how you would write it with a positive exponent. This is how you would write it with a negative exponent. All right, let's continue to practice this. If we look at the next quotient, I've got a to the 4th power in the numerator and a to the 9th power in the denominator. So again, every time I have a divided by a, I'm going to cancel that out. So I can cancel 4 on the top and 4 on the bottom. That's going to leave me with 1 over 1, 2, 3, 4, 5, a to the 5th power. Now, if I went strictly by the quotient rule, which again says if I am dividing the same base, I subtract the exponents. So that would be a to the 4 minus 9 power, or a to the negative 5th power. So what I want you to understand once again, 1 over a to the 5th is equivalent to a to the negative 5th. So you'll start noticing that the exponent in both cases is positive when it's in the denominator, but when we bring that up to the numerator, it becomes a negative exponent. All right, let's look at this next one. 4 squared on the top. One more. 4 to the 10th power on the bottom. I can cancel out 4 times 4 with 4 times 4, and I'm left with 8 4's multiplied by itself. That would be written as 1 over 4 to the 8th power. If I use my quotient rule, it's 4 to the 2 minus 10, or 4 to the negative 8 power. And once again, you'll notice this is the same as this. It's just written in a different form. Positive 8 exponent in the denominator, negative 8 exponent if I move it up into the numerator. Now, if we want to write the original quotient that would go with this repeated multiplication model, it would be x to the 3rd power on the top. 1, 2, 3, 4, 5, 6, 7, x to the 7th power on the bottom. You can see that this would leave 1 over x to the 4th, or if I used my quotient rule, x to the 3rd minus 7, 3 minus 7 equals negative 4. And again, this is equivalent to this. It's just written in a different form. Your lesson today is going to be going from positive exponent to negative exponent and negative exponent to positive exponent. And what you'll realize is you just have to take it over the fraction line, and that's what changes the sign. Now, this next one is way too much to expand out. I'll show you what it would look like, but we are going to write it a different way. Here is what it would look like. Lots and lots of writing. We don't really have to do that. Let's shorten that up a little bit. And let's write it like this. Let's just take each individual variable. Let's start with our a's. And it's a to the 4th divided by a to the 9th. So that's the same thing as a to the 4 minus 9, or a to the negative 5th power. If we do our b's the same way, b to the 5th over b to the 12th power, that's going to be b to the 5 minus 12, or b to the negative 7 power. So, if we wrote that as a fraction with a positive exponent, it's going to be 1 over a to the 5th, b to the 7th. Notice it makes them positive in the denominator, but then if I want to write it with a negative exponent, it comes up to the numerator. And again, this is equivalent to that. Okay, so what does a negative exponent really mean? If we look at our two columns on the right and we try to make a rule, the way I would write it in simplest form would be an exponent in the denominator is the same as a negative exponent. Now, if we think about the next question, are positive expressions with negative exponents considered negative? The answer is no. And I'll show you a couple of examples. If I have 2 to the negative 3rd power, that's positive. The 2 is positive, right? So if I were to solve this using my rule that says I can put it in the denominator, and that makes that 3 positive 3, then if I simplify that, that would be equal to 1/8. 1/8 is positive, isn't it? So having a negative exponent does not make the number negative. Let's look at one more example. If I have 5 to the negative 2nd power, that would equal 1 over 5 squared, which would equal 1/25. And again, both of those are positive. So just because it has a negative exponent does not make the number, the base number, negative. Look at the next question. What do you think this simplifies to be? 1 over 2 to the negative 3rd power. So if we work that out, remember that the fraction line changes the sign. So this time we have the negative exponent in the denominator. So we're going to bring it up across that fraction line, and it's going to become 2 to the positive 3rd power, which is 8. Okay? So moving it across that fraction line changes the sign of the exponent. Here's the algebraic rule. If you have a to the negative nth power, that's going to equal 1 over a to the positive nth power. So you can just remember that rule. Now let's practice a couple. This first box is asking you to use negative exponents. So remember, the way we're going to turn this into a negative exponent, if it's a positive exponent, is to move it across the fraction line. So if we move that up, it becomes 2 to the negative 4th power. If we move it down under 1, it becomes 2 to the positive 4th power. On this one, it's positive in the denominator. If we move it up, it becomes negative in the numerator. So it gets the opposite sign when it crosses over that fraction line. And the last one, now this is a little tricky because you've got something other than 1 up there in your numerator, and it stays there. It doesn't move. That 5 doesn't have an exponent, so it's going to stay in the numerator. But I'm going to bring that a to the 6th power up, and it's going to make it a to the negative 6th power. Now, I told you guys in class today that normally they're not going to want you to leave negative exponents in your answer. So read your instructions very carefully tonight, because it may tell you to leave negative exponents, or it may tell you to write it with positive exponents. So make sure you pay attention to the instructions. Now, these are negative exponents, so I'm going to move it down. And it's going to become 6 to the positive third power. I'm going to move this one down, and it's going to become n to the positive 2 power. And here again, I've got a 4 up there, so I'm going to leave it alone. But I'm going to move my x down so that it will make that 3 exponent a positive 3. Okay? Your homework tonight is in your textbook on page 502, 14 through 29, all. We'll go over that tomorrow in class.